Okay, besides the transistor, basic of transistor, now we'll look at the transistor circuit. Okay, so the if you want to draw a basic transistor circuit, you know transistor is the one to control the AC load. We must use the AC power. So the reason is AC power, when the voltage goes negative, it helps turn off the transistor. So that's why for this reason, for this reason, most of the transistor are used in the AC circuit. Okay, so I'm now drawing you a transistor here. So basically, transistor just like a diode. You see, it allowed current to flow through only in one direction, in this direction only. Okay, pointing by the arrow. When you flow reverse, you're blocked by this transistor. Okay, so we have the one gate here for us to control. Okay, so this is a gate, this is the anode. Okay, NODE, cathode. Make sure you know how to pronounce this one, cathode. This is a gate. Okay, so let's imagine we got one load here, and this load is a resistive, pure resistive load. Okay, let me draw a circle. Let's imagine this one is a load, is a lamp or something. Okay, so lamp is basically just a resistive load. So what we do is we just connect this line to the lamp and this line to the other terminal of this AC power supply. Okay, so let's imagine this one is a 240 volt you can call VAC is okay, okay, AC voltage, AC voltage. Don't need to say the VRMS. Okay, VAC means AC voltage. Okay, so when this circuit is connected, the lamp cannot turn on, right? Then the lamp cannot be turned on because there's no current flowing through. There's no forward current or anode current flowing through this transistor to power this lamp. So we need to send some kind of pulse to this gate here. So what we can do is, the pulse is only what we need is something like a milliampere. So it's a really small current that is required to turn on the transistor. So what we do is, here we use one first we use one fixed resistor. Okay, use one fixed resistor to play safe. Let's say this one is 10K, so 10K can reduce the 200 volt into something like milliampere. Okay, and then here we add another resistor which we can adjust. Okay, so this is a terminal here we can adjust. So this is the sometimes we call it the potentiometer. Okay, this is the something like this. Okay, sometimes we call it the potentiometer, or we call it a reliable resistor. Okay, so this one we use about 100K. Okay, so we can adjust here to be from 0 to 100K here, and then here we put one capacitor. I think you've seen this one in the lab, right? In the lab we have this circuit, and then this one is the output here. So the current is really small. You can see the current here need to pass through 10K and 100K to charge this capacitor. So this current is very small, and this waveform is similar to this one, but the magnitude is smaller. For example, let's say this is your AC. Okay, let's say this is your AC here. Let's say here is a VM. So the V here, the VG here is very small. Okay, very small. And the current, how small is this one? Is about less than 40 volt. So it's very small. Okay, it's in phase with the AC. So we use this small voltage here to turn on the gate. Okay, to turn on the gate here, because this capacitor, the charging rate is slow. When the capacitor first charge to, let's say have this capacitor voltage here. So capacitor voltage, when the capacitor voltage charge to certain voltage here, okay, and then this will turn on. So this is capacitor voltage here. So let me follow this. This is exactly the same phase. So the capacitor voltage is something like this. Okay, so we call the VC capacitor voltage. So when this capacitor voltage reach certain level, let's say this level, indicated by the cross here, the voltage is high enough to turn on this gate. Okay, so in order to ensure this voltage is above 30 volt, so we use one diode here. Okay, we use one diode here to make sure the voltage is above 30 volt, that the current can flow through it. Okay, let's draw a diode here. Oh, okay, now one more time. Okay, something like this. Let me show you. Something like this. Diode. Oh, that's something like this. Okay, I've got it wrong way. This is the valve. This is the valve, not diode. Okay, we use a diode here. One triangle, another triangle. Okay, so this diode is about is dB2 lah. The name is called dB2. So after the voltage, when the voltage above 30 volt, then you will pass through. Okay, when the voltage below 30 volt, you cannot flow through, just like diode. Okay, diode got forward voltage drop. Okay, so this is so when this VC here, when the VC, the capacitor voltage reach certain level, you can turn on this transistor, and what you see on the output here, if you look at the output here, V out, you'll see after when this capacitor voltage reach this level, and this AC will transfer to the output, but no negative. Okay, no negative here, because negative will blocked by the so the output look like this. So here is pi, here is a 2 pi, pi to 2 pi is nothing. Then after here again, it will come up again. Okay, just like this one, same size. Okay, same size actually. Let me draw the same size here. Okay, same thing. So here you can call it beta also can. From here to here is a beta. So beta is the firing angle. We call it firing angle. Okay, so if this one, the load, if the load is the inductive load, is a heavy inductive load. Okay, if the load here, if the load is heavy inductive, okay, so what happened to the output here, you know, there's a, what happened to the outputs like this. Okay, let's say it's a pi here, let's say it's 2 pi here. So the voltage will flow because this one will slow down the current, and then that's why the current will part over the pi, over the 180 degree. Okay, the current will flow over 180 degree, and this is the current. The output current will be slowed down. Okay, actually let me draw a better one. Okay, this is not the voltage. The current usually is lower. Okay, let's draw a lower output current. So the current is something like this lower. And actually the current will be slowed down because of this inductor. The current will slow down. What do you mean slow down? We have some delay. Some delay. Okay, let me use a red color. So delay like this. You will slowly go up, and then like this. Here is really slow down. Okay. Then for the output, as for the output voltage, here you will turn on. Here turn on, and then the output voltage also follow this current. We will pass the 180 degree. Okay, it will pass 180 degree like this. But the voltage is in phase. Okay. Okay, let's draw a better one. Let's say this is a pipe here. The voltage will be in phase, just like this one. Okay, in phase. You will go to 0 at pipe, unlike the current will over the pipe. Okay, this is a V out. When you use the inductive load, okay, this is for resistive load, R. This is for inductive load plus resistor. Okay, small resistor but a big inductive load. And then here, well, go over here, like this. So you can see here a positive voltage, here's a negative voltage. So overall, the VDC or the VRMS will be smaller. We will reduce output voltage. So if you use a heavy inductive load for this transistor and for this AC voltage, the output voltage, output voltage, this average, the average output voltage will be decreased. Okay, you'll be reducing, decrease when you use the inductor. So to solve this problem, actually we can solve this problem. You should remember, right? I explained in the classroom. We just use one freewheeling diode here, so that the current in the inductor here will flow and recycle here. Okay, that's why this one will bring the output here back to here. There is no negative. Okay, no negative after you use we call the freewheeling diode. Okay, this is really important. This is a really important component in the power electronics. So if you don't know this, probably you should retake. Okay, this is called freewheeling diode. I explained it I think a few times already. This, just use one diode here, you can take away this negative waveform here. Okay, and then actually there's another way facing by this transistor. Okay, now we're talking about the output voltage. Okay, just now we talked about the output voltage. So what I want to talk about next is the what I want to talk about next is the what is the problem faced by this transistor. Okay, the problem facing by this transistor. You see, let me draw the transistor again. Let me quickly, because I try to don't want to drag too long the video. So this transistor, okay, will face some problem, including the previous circuit. Okay, you can draw the previous circuit here. We will face some problem. First, if the current flow through the transistor is too is changing too fast. Okay, this one we call the a high DIDT. You should know what is DIDT, right? DI is a change of current, DT is change of time. That means when people say high DIDT, it means this is a current, this is a voltage, the current will go up so fast. Okay, when DIDT equal to 0, it's like this, the current like this. There's no change, no slope. This one you got slope. Slope is the DIDT. This is no slope. DIDT equal to 0. You learn this one in the secondary school. Okay, so when high DIDT, something like this passing through the transistor, actually you can destroy the transistor. Transistor will die. Okay, transistor will die when you putting a high DIDT through this inductor. Okay, but to solve this problem, what you can do is you use one inductor. Okay, you place the inductor in series. Okay, in series with the transistor, because the inductor will slow down the current. When you have this kind of current, okay, I and T going to through the transistor, when you put the inductor here, the current will like this. You'll slow down. Okay. So this is the low DIDT. The slope is really low. This is the slope. So the DIDT, the DIDT is here is higher. The slope is very stiff. This slope is low. The slope is lower. This slope is very high. Okay, so this one can protect this transistor, prevent it to be destroyed by the high DIDT. Okay, so another problem faced by the transistor is the high DVDT. Okay, another problem is high DVDT. Okay, I run out of time already. Taking too long. Okay, I need to finish fast, otherwise it will take too long to upload the video. Okay, the other problem faced by the transistor, you can draw the complete circuit, right? I don't want to waste too much time here. You complete all the circuit here. Okay. Another problem faced by transistor is the high DVDT. So what do you mean DVDT? High DVDT means suddenly you connect this power to this transistor circuit. Let's say you have got one switch here. So when the switch is closed, suddenly you got very high DVDT. It's the same thing here. This is the voltage. This is the time. Is the voltage changing too fast? From 0 volt suddenly you jump to 900 volt. If you apply to this transistor, what happens is this transistor will turn on. It will turn on without the gate current. Okay, one more time. If you use high voltage, high DVDT, you apply to the transistor. Okay, suddenly you apply high voltage to a transistor. What happens is transistor will turn on by itself. It will turn on without the gate current. Without gate current. That means when you turn on the power supply, transistor also turn on. You don't need to control. It's already turned on already. So in order to solve this problem, we can use one called the snubber circuit. Okay, this circuit, the name is called snubber circuit. You can go Google it. Okay, Google, you see, if you type snubber, it looks like this. Okay, looks like this. We can buy actually, but the circuit looks like this. Circuit looks like this. Stubble diode. Okay, so what you do is you take one resistor about 10K, and then you put use one capacitor here. You put a parallel to the anode and cathode. Okay, parallel, so that this resistor will charge up this capacitor slowly. So you charge up slowly. Otherwise, the voltage will go up so fast. Okay, so your charge up slowly the capacitor voltage here, the VC. So you charge up slowly, and this one can prevent this one from turn on by high voltage here. Okay, we suddenly apply high voltage, this one will turn on. So if you use RC circuit, RC here, RC, where is it? Here, RC. So this is a switch, right? This is a switch. This is our transistor. So you put the RC circuit here. They call the RC snubber circuit. Okay, here also can, you see. So this is a transistor, right? Something like transistor. This is a transistor, right? Okay, this is a Triac. You see, they put the RC here, and then put the S, RS, CS. S stand for snubber circuit. Okay, just now we got freewheeling diode. I call the diode DF. F stand for freewheeling diode. Okay, so this one is to prevent the high dividity. Okay, I hope you remember.